Hello everybody, let's keep learning as domain analysis module for continuous system. Hello students, next we will use Laplace transformation and its convergence domain, teaching Laplace transformation for several typical signals. First, we look at the step signal epsilon t. We know that the step signal epsilon t, when t is greater than 1, epsilon t equals 1. When t is minor than 0, epsilon t equals 0. So we can use the unilateral Laplace transformation formula, putting the step signal epsilon t into the unilateral Laplace transformation formula. E to the power of negative st from 0 integral to positive infinity. This will solve this integral. When delta is greater than 0, fs is equal to 1 over s. That is, the Laplace of epsilon t is converted to 1 over s. Convergence domain is delta is greater than 0. Let's look at the exponential function, the Laplace transformation of e to the power of negative alpha t. Using a unilateral Laplace transformation, put the exponential function of e to the power of negative alpha t. Substitute into unilateral Laplace transformation formula. Solve this integral when alpha is greater than negative alpha. Fs equals 1 of the s plus alpha. That is, the Laplace transformation of e to the power of negative alpha t is 1 of s plus alpha. Convergence domain is alpha is greater than negative alpha. The same way, we can obtain e to the power of alpha t. Laplace transformation is 1 of the s negative alpha. Convergence domain is delta greater than alpha. Then look at the Laplace transformation of the unit excited signal delta t. We know that the unit excited signal is delta t. When t equals 0, it is infinity. When t is not equal to 0, it is 0. Depending on the nature of the function delta t, ft to the value from 0 to infinite value f0. Substitute into the unilateral Laplace transformation formula. It can be obtained. Its value is y. That is, the Laplace transformation of delta t is transformed into y. Convergence domain is full plane. Example, negative infinity to positive infinity. The Laplace transformation of delta t to t0 can be obtained by the same formula. Its value is the e to the power of negative st. Convergence domain is also from negative to positive infinity. Similar, the Laplace transformation of the burst signal derivative can also be sought. The value of the delta t is s. Let's solve the Laplace transformation of e to the power of j beta t. We solved e to the power of negative alpha t before. Laplace transformation of beta t. Its value is 1 of the s plus alpha. Here, we can take j beta as negative alpha. So you can get the Laplace transformation of e to the power of j beta t is 1 over s minus j beta. Convergence domain is delta greater than 0. The Laplace transformation of e to the power of negative j beta t. Its value is 1 of the s plus j beta. Convergence domain is delta greater than 0. Let's take a look at the Laplace transformation of n to the power of t beta. Let's take a look at the Laplace transformation of n to the power of t epsilon t. Put n to the power of t, substitute into unilateral Laplace transformation formula. You can get t n sub side multiplied by e to the power of negative st, points from 0 to infinite. According to the distribution integral method, you can get its integral value, as shown in the formula. Integral values from 0 to infinity. This value is equal to n over s. Laplace transformation of t to the power of n minus 1. That is, the Laplace transformation of t's m side can be obtained by the Laplace transformation of t to the power of n minus 1. So we can first solve the Laplace transformation of t. It's easy to get t's Laplace transformation. It is 1 over s to the power of 2. You can get it according to the Laplace transformation of t to the power of 2. Its value is 2/3 of the 3/4 of s. And then according to the Laplace transformation of t to the power of 2, you can get the Laplace transformation of t to the power of 3. Its value is 6 over s to the power of 4. Similarly, the Laplace transformation of t to the power of m. Its value is factorial of m over s to the power of m plus 1. Okay, that's all about it. Thank you.